The custom board that I designed, working for Coroware, has got a Cypress PSOC 5, which is a ARM M3 based microcontroller with a bunch of RAM and some very high-end configurability and a USB interface. This thing interfaces over USB, and we made that choice because what we didn't want to do is break the things that make the Raspberry Pi the Raspberry Pi. It's a Raspberry Pi hat, which means that it plugs into the top of the Raspberry Pi and interfaces intimately, providing power, but we're bringing all of the connectivity straight up through the board. You don't lose any of your Raspberry Pi IOs. You do have, we did bring over the configuration pins so that after the production version of the software is released, there will be a package you will be able to install, and this thing will configure the Raspberry Pi to load our software at startup by detecting the presence of the hardware. It's got two PSOC 4s, which are microcontrollers also made by Cypress. They're ARM M0s with some less functionality, but they're sub-processors, and those run the wheels.
So you mentioned the PSOC 5 and the extra functionality and the extra configurability it has. What does that mean for taking something beyond your basic Blink into maybe creating some analog bits around your microcontroller?
The reason I chose that for this design is we didn't want to make a toy robot. We wanted to make a robot that's usable by children, but we didn't want to make it a toy robot.
Right.
First of all, this, just like our professional robots, is a four-wheel differential drive robot. And that means there's an individual motor for each wheel, and they're individually controllable. And that means that this robot has an exceptional maneuverability. It means that it can turn in its own footprint. It also means that it takes a little bit more processing power to make it go. We didn't want to take that processing power out of the Raspberry Pi, which had, at the time, limited compute power.
Although, as we discussed last week, they've kicked it up a notch with the Raspberry Pi 2, which
and this thing is going to be an incredible combination with this robot, because the PSOC 5 means that we have a lot of configurable I/O on one edge. And the way that I've chosen to configure that, and over the long haul, we intend to get some end-user feedback and tweak that as appropriate. And the PSOC 5 gives us an enormous amount of flexibility to tweak that going forward as we need to.
And is that tweakability available to an end user who wishes to get in there and assign those IOs themselves?
Not immediately.
Okay, so that's part of the eventual plan?
That is the eventual plan. In the short run, we intend to release a proprietary firmware with updates.
Very cool.
And over the long haul, we intend to engage with the end user community and put together a more configurable and more flexible firmware. For the moment, we're retaining control of the firmware because not all of the hardware details have been worked out.
Right.
And we want to have a little bit more control until we have a good grasp of how the hardware is going to behave in a production environment.
Sure.
But ultimately, we plan to open source the firmware. Ultimately, we plan to use a very similar firmware in our higher end robots, which will be coming out over the next year to year and a half.
Fantastic. So this is something that you'll be able to take from this platform and apply to other platforms, apply to lots of professional platforms that Coroware currently produces?
Not the ones we currently produce, but the ones that are upcoming.
Okay, so that's pretty exciting, because I've seen what you guys put out, and it's pretty impressive.
Yeah, and it's going to get. I'm obviously not at liberty to say everything that I know, but I am going to say that that's going to improve substantially in the next year to year and a half.
All right, fantastic.
What we did is I made the input-output on the Pi hat that we built 5 volt. Now, the Raspberry Pi has 3.3 volt I/O. Now, there's a lot of stuff for Arduino that's 5 volt. There's a lot of legacy sensor stuff that's 5 volt. And there's a lot of 3.3 volt hardware out there by a million manufacturers. Having a combination of 3 volt and 5 volt connections means that you've got 3 volt power, 5 volt power. You've got all of the connectivity to sensors from both of those. And essentially, what it allows you to do is do nothing more complex than build a cable and attach pretty much any sensor made by pretty much any manufacturer in what, the last 10, 15 years?
Absolutely, absolutely.
And what I built into this board, in addition to the 2 front ultrasonics, which come standard, not only do the connections come standard, the sensors themselves come standard.
And the mounts.
And the mounts come standard. Front and rear infrared distance sensor. And the Raspberry Pi camera with a pan tilt mount. We also include
Mount right here.
We also include the Raspberry Pi itself, the motors, the chassis parts. I mean, it comes some assembly required, but we're running the kit at $400,
which is amazing, because that's, for that price in today's market, what you get is a Lego NXT, or
you don't even. Unfortunately, at this point, you're not even buying a full Lego NXT.
That's true. You get the brain for around that price now, and unfortunately, that is very limited. You can't really use that for a whole lot outside of your basic robots. You can't do a whole lot of machine vision. You can't do any open source, any extra builds on top of that. It's very restricted, very limited, which unfortunately restricts and limits anyone who's working with its creativity and design ability. So what we're shooting for here with the Corobot Spark is something that is accessible at that level, at the NXT level, for any age, and completely.
And it'll grow with a student.
Yeah.
Is that the problem with the low end stuff is it's got a bad problem with growing, which has been an ongoing problem in the educational community. The other problem with Lego NXT is the hardware is actually quite good.
It is.
But the software environment has been problematic for a lot of educators.
It has been. The EV3 release was actually pretty impressive, and has allowed some extra options along the versatility of design route. But up until this point, students grow out of their hardware and their software and grow into new things. The Corobot Spark grows with them.
Now, one of the nice things, you take this unit, you attach it to a Raspberry Pi. All of the tutorials that work on the Raspberry Pi still work. We don't break any of the existing curriculum.
Which is fantastic.
And I put in a tremendous amount of work to ensure that we didn't break any of the existing curriculum. The other thing I did is I provided a lot of uncommitted I/O. The robot comes with a very heavy sensor load for something its size.
Absolutely. Now, what do you mean by uncommitted I/O?
Okay. A committed I/O is one that's used for some part of the robot that ships standard.
Okay.
So if I'm using an output to drive a motor, and the motor is on a wheel, that's committed.
Absolutely.
The ultrasonic sensors, that I/O is committed. The infrared rangefinders, that I/O is committed, because I gave you a piece of hardware in the kit that uses that up.
Sure.
Now, can you take it off and put something else there? Yeah. It's an open platform, there's a lot of flexibility, you have the power to do that. But I'm going to assume that most of the people are going to want to use the functionality that we provide and not take anything away. But they probably want to add things.
Absolutely.
Maybe they want to add a string of multicolor LEDs. Maybe they want to put headlights on it. Maybe they want to make it sing. I don't know.
A singing robot.
I don't know. Well, the Raspberry Pi does have the right outputs for it. It really wouldn't be that hard.
It really wouldn't. I mean, it even has the audio jack. You can run whatever you want out of it.
You need some kind of little amplifier, but I mean, maybe we do a project for that. I don't know.